If you are a Python developer and still using vanilla PyTest, then you are doing it wrong. Let me show you how to transform your testing workflow with PyTest plugins. Let's get started. So the first plugin is a must-have for everyone. Maybe you noticed that your tests take a long time to finish. It's probably because PyTest runs the test cases in sequential order by default. Let's take a look at a small example where I have 3 test functions where each test function will wait for 5 seconds. Now when I run pytest, you will notice that it takes 15 seconds to finish. And that's because pytest runs every test function in sequential order. Since your tests are hopefully not dependent on each other, you can parallelize the test execution. The plugin pytest-xdist does that for you. It lets you run your tests on multiple CPU cores in parallel and therefore speeding up your test executions. For that, you first have to install it, and then you will run pytest again, but with the -n flag, where you can specify the number of workers. In this case, I will specify the number 3 and run the test cases again. And here you can see it. The test execution finishes after a bit over 5 seconds. Please use this plugin to speed up your test executions. So the second plugin is regarding environment variables. And nearly every app uses environment variables. But specifying them in your tests can become a headache since you need to isolate the test environment from the local environment. pytest-env simplifies this by defining your env variables in your pytest.ini file. Hence, it allows you to define env variables for your tests and ensures you do not interfere with your local environment. To see it in action, let's look at a small example. I have again one simple test case where I just have a simple assert statement to check for an API key in my environment variables. What I need to do now is installing the pytest-env plugin with pip install pytest-env and then going into my tests folder and creating a pytest-ini file like so, and then defining my environment variable. In this case, I need a pytest header and then env equals API key, which is equal to 1, 2, 3, 4, 5. We save that and then we run pytest, but with our pytest-ini configuration. So we specify -c and then the path to our pytest.ini file. And we can see that everything works fine. So whenever you are working with environment variables and want to separate the test environment from the local environment, consider using pytest-env. The next plugin is for calculating code coverage. Code coverage is a metric to measure how much of the source code is executed during testing. So let's look at a small example. I have created 4 functions where you can add, subtract, multiply, and divide 2 numbers. And I created a test file where I test the add function and the subtract function. And now for calculating code coverage, first we have to install the plugin pytest-cov. And now we run pytest with --cov equals to the folder where your source code lies in. And now we can see the code coverage calculated for us for every file. And in this case, 75% of our app file was covered by our tests because we didn't create the tests for our multiply and for our divide functions. What you can also do for your CI pipelines is defining a minimum coverage number with --cov -fail -under equals to, let's say, 90%. And now we can see that it failed because 75% is obviously under 90%. The next plugin is useful whenever you are working with Matplotlib. So when you are working with Matplotlib to generate plots, how do you test the output? It can be a bit difficult, to be honest. But with pytest-mpl, you can do that easily. For each figure to test, an image will be generated and compared to an existing reference image. If the difference is larger than a user-defined threshold, the test will fail. So let's see it in action. So first you have to install pytest-mpl and of course Matplotlib. And then you will need a test function which will create a figure, and it's important that it has to be a Matplotlib figure. In this case we have a simple test plot function where we just create a plot. And it's important to mark the function with the pytest.mark.mpl image compare decorator. And then go to your terminal, and you have to first create the reference images. And you will do that by running pytest-mpl -generate -path equals to the path where you want to store your reference images. In my case, I want to store them in test/baseline. Now we can see we have created a new baseline folder and our reference image. And now when we want to test our plot function, we just run pytest-mpl. And we see it passes. But now let's change something here. We will not do xplot 1 and 2. We will do 1 and 100 or 200. And now when we run the test again, we see that it failed. One great thing about pytest-mpl is that you can also generate an HTML summary. And you can do that by adding the mpl generate summary equals HTML option and the path where you want to store the HTML file. And now when you run this, you will see a thick comparison HTML file. And when you open it, you will get to this page. Now we can see our plot here. We can click on it. And now we can see the differences between our reference image and our newly generated image. So whenever you are working with Matplotlib, consider using this pytest plugin. So the next plugin is fixing our really annoying pytest behavior. So let's look at a small example. I have 4 tests where the first test will always fail and the other 3 tests will always be green. Now when I run pytest, I see that my first test failed, but I can't see instantly why. So I have to wait for the other tests to see why my first test failed. And that's really annoying, to be honest. So with the plugin pytest-instafail, you can immediately see the failures and errors of your tests instead of waiting until the end of the test session. So first we install pytest-instafail. And then we run pytest again, but with the instafail flag. And now we can see immediately what went wrong in our first test, instead of waiting for the other tests. The next plugin is more a nice to have than a mandatory plugin in my opinion, but it's still pretty useful. So sometimes, even without noticing, you have some inter-test dependencies. That means that one test is dependent on another test, which is not what you want, because your test cases should be independent of each other. But sometimes this can be hard to detect. The plugin pytest-randomly runs your tests in random order to reduce the risk of such dependencies. What you have to do is install the pytest-randomly plugin, like so, and you run pytest again. But if you want a specific seed, you can also specify that by --randomly -seed equals to 1, 2, 3, 4, 5, 6. And now you can see that it picked up our random seed. The last plugin is the one plugin which helped me a lot in my projects. So whenever you are working with many APIs, you will find yourself write dozens of mocks for your tests. This can become very cumbersome in my opinion. But a different way to work with APIs in your tests is by using the plugin pytest-recording. Pytest-recording records any API interaction once and replay it offline forever. That means it saves the whole interaction with all APIs when you run your test the first time by automatically capturing responses and saving them into a YAML file. It then uses the saved interaction for any subsequent test run. Therefore, you do not need to mock anything. So let's look at a small example. So I have a function getUser where I make a request to the JSON placeholder API and just grab one specific user and return the data of it. So when we look at the JSON, it looks like this. Now I also wrote a test case for it, but to be honest, I don't want to mock it because maybe my project will involve more and more API calls and I don't want to mock any API interaction because this can really be a headache for me. But luckily we can use pytest-recording. So first let's install it with pip And then we need to use the pytest mark VCR decorator, because we have to tell pytest that we want to save the API interaction. Now when I run pytest, but with the record mode equal once flag, I say, hey pytest, save the API interaction for me, please. And now what we can see is a new cassettes recorder was created for us, and here we can see the YAML file for it. And this YAML file includes the whole interaction between your machine and this API here. So when we scroll a bit down, we can see the method was get. So we can see the body, unfortunately in binary mode, so it's not really human readable. We can see all the headers, even the status code. And that's great because we need to do this only once. And now when we run pytest again, but just pytest, we will not do any real HTTP requests, but pytest will use the data from the cassettes folder, in this case from the test get user data YAML. And that's great because any subsequent run will just use the recorded response instead of making real HTTP requests. And this is how we can save so much time instead of creating many mocks. So whenever you make an API request where you need an authorization header, for example with your API key, by default pytest-recording will also save this in the YAML file, which you will not want to do. For this case, you will have to set the VCR configuration. In this case, you will create a dictionary and you have the filter headers, and you want to say that authorization should be filtered. And with this, you can make sure that no API key will be saved in your YAML file. I hope you learned why these pytest plugins will transform your testing workflow. If you liked this video, smash the like button to see more videos about Python and data science in the future. And comment with your favorite pytest plugin. Bye bye.